All right, we are going to get underway. For those of you who have never come to a workshop before, my name is Bruce. I'm running the show here, but I see a lot of familiar faces as well, so welcome back to all of you. Couple of minor housekeeping notes just before we start. Number one, if you haven't filled in the sign-up sheet, fill it in. We love to know who came and who didn't. Well, not that we know who didn't. That was a reflex. Anyway, the other thing to note is if you've never been to one of these workshops, we have a system of visual cues that we use. You'll have next to your laptop or somewhere near your seat a blue Post-it note and a pink Post-it note. If everything is going fine, if everything's working all right, if you are not having any trouble whatsoever, take the blue Post-it note, stick it on the top of your laptop, and one of our helpers, who should self-identify right now, just so people know, they have their hands up, if anybody's looking, yep. They'll be around to help you. The pink Post-it note is for, if you need help. I think I may have crossed my wires there for a second. The blue Post-it note means everything is fine, you're ready to go. If you need help, grab the pink Post-it note, stick it on top of your laptop, and that will let one of the helpers know they should come around and help you. And that can be for anything. If you're having problems with your environment, if you're having problems with your code, it's not running properly, you don't know what to do next, then just grab that pink Post-it note, put it on top of your laptop. Okay, let's get started. So, Last lesson we covered some early data visualization with plotting, and we also started in on some more specific ways to access data in your data frame. We started to talk about slicing, to talk about indexing, and how to extract specific subsets of your data. If you'll recall, where's my cursor? There it is. The last few things we did were to select some specific rows from our data set. So we've shown that you can select a single specific column. You can select a set of columns, and you can select a set of columns that will be returned in the order you pass it. And if you try to get a column that doesn't exist in your data frame, you get this lovely, lovely key error telling you that you can't do that. Pardon me. So, building right off from that, we are going to continue talking about slicing, which is if you don't want a whole column or a whole row, you just want to get a small slice of your data set. We can pass specific indices to a data frame to tell it to return just the subset of data that we want. One thing to keep in mind as we're going forward with this, Python uses zero-based indexing. So that means that the elements of a data frame are not, if there are 5 elements in your data frame, it's not 1, 2, 3, 4, and 5. It's 0, 1, 2, 3, and 4. This can be a little strange if you've worked with languages like R or programs like MATLAB, which use 1 indexing. So the indices would be numbered 1, 2, 3, 4, and 5. But Python starts at 0. And in fact, if we scroll up to some of the data we looked at before, we can see in this bolded number on the left, which indicates the index number, it starts at 0, and it goes, in this case, to 35,548, even though there are 35,549 entries in our data frame. So that's just something to keep in mind while you're slicing data to make sure that you get the information that you want. So I will show you how to do some slicing. But first, we're going to just do a quick little at your desks challenge to cover some basic data extraction. So what you're going to want to do is create just a simple list of numbers. The way you do that in Python is you're going to say A equals, where A is just our variable name. We're just, lists are assigned to variable names the way any other variable would be. We're going to open our square brackets, which is how Python knows it's dealing with a list. And I'm just going to put in 1, comma, space, 2, comma, space, 3, comma, space, 4, comma, space, and 5. The spaces I don't believe are necessary, but they do make your code more readable. I like to use them. You don't have to. And then if we hit Shift-Enter to run that cell, there's our list made. If we print it out, we can see 1, 2, 3, 4, and 5. So once you have made that, I'm actually going to go ahead and see if I can just pop this up here. Yeah, okay. So once you've got that, I'm going to leave this up for you to just take a couple of minutes and do. Work your way through these. First of all, what value does the code below return if you try to index the 0th element in the array? You can try this one, indexing the 5th. And maybe work on these too. Think about some of the answers that you might get. I'm going to leave that for you to work your way through. And I'll be back in just a couple minutes to see what your answers are like. So yeah. Okay. Now that you've all had a chance to try out some of the code in this challenge block, is this, incidentally, just while I've got this here, is this a readable size for everybody? Can people in the back see this okay? We're good? All right, cool. Now that you've all had a chance to take a look at this, does anybody want to take a stab at what happens when you run this? A, open square brackets, close square brackets, 0. Correct. If we go back to our code, we type a, give a little space so that we can see that. A, square brackets 0, we do indeed get 1, because 0 refers to the first index in the array, which is, as you'll recall, 1. What about this one, A5? A square brackets 5. Anybody want to take a stab? Correct. You get an error. Why is that?
Because 5 isn't an index, it's not equal to value, so there's no thing indexed at 5 because it starts at 0.
That is correct. If we try to do A of 5, we get an index error. List index is out of range. Because it's 0 indexed, these are indices 0, 1, 2, 3, and 4. There is nothing at the 5th index. And finally, what about this? What do we get if we try to run A and we get the index that's at length of A? Sorry? Correct. If we do this, a len, which is a function that means length, short for length. If we do that, we get the same thing because the length of A is 5 elements. So even though the indices go 0, 1, 2, 3, 4, the length of the array is 5. Incidentally, you may hear me use the words array and list interchangeably. That's because my brain is broken from having learned Java first. In Java, the same data structure is called an array. In Python, it's called a list. Strictly speaking, you should just say list when you're dealing with Python, but I have been known to use both. So I apologize in advance if that's confusing. But okay, now that we know how to do some basic array indexing, let's get on to slicing some subsets of rows in Python. Let's get back to our data frame. Slicing uses the same basic syntax as array indexing, but with one crucial difference. So let's just make sure I've got my surveys data frame here before I embarrass myself. Yep, there it is. It's our very familiar data frame containing all of our survey data that we've been toying around with. So let's say you want to get just a slice of it. You don't want the whole data frame. You just want little chunk of it. So suppose we wanted to get, for example, the first 3 rows. Whoops. Sorry. My bad. Suppose you just wanted to get the first 3 rows. The way you would do that is by typing surveys underscore df, which is what we've called our data frame. Incidentally, you may want to make sure that this variable still exists. You can do that just by typing surveys underscore df and hitting enter. If it doesn't exist, you may need to re-import your data frame, which you can do with these 2 lines of code right here. You probably have a cell that looks a lot like that in your code. If you find it and run it again, it'll recreate your data frame. If you already have surveys underscore df, you're fine. You're good to go. Give everybody a second to look at that in case they need it. And we'll get on. Okay, so continuing. All right, so if we want to get the first 3 rows, the way we do that is this. We get our data frame, such as it is. We open our square brackets and we type 0, and then a colon, and then 3. And if we print that out, you can see we get the first 3 rows of our data frame, 0, 1, and 2. So this stop bound might seem a little strange because we're giving it 3 as our stopping point, but we're getting rows 0, 1, and 2. When you slice an array or data frame in Python, the numbers you give it are the start bound and the index just after the one you want to select. So if you want to get the first 3 rows, 0, 1, and 2, you have to give 0 and 3 as your bounds. We can also do a few other interesting things with slicing syntax. We can, for example, omit a bound, which looks like this. Surveys underscore df, open square brackets. If you just type colon and a 5, like so. So if you don't supply a start bound, then it'll automatically assume you want to start from the beginning of the data frame. So if you don't supply a starting bound, you just give it an ending, like a stop point, it'll assume that you want to go from the beginning. This works the other way too. If you don't supply an ending bound, if I, for example, say surveys underscore df 35,540, and I don't give an ending bound, it assumes that we want to go right to the end. It'll go from whatever we give it straight to the end. I'm seeing a couple of red sticky notes, so I'll just give everybody a chance to catch up, slow down a little bit, make sure that we're all good. In the meantime, feel free to play around with the slicing syntax and see what you can generate. Oh, yes. No problem. Yeah. I'll take a few of the lines out of this just so that there. All right, we are going to keep going here. All right, so thank you, everybody. All right, so we've seen how to slice up some data. The next thing we're going to cover is how to reassign values in our data frame. But there is an important little hitch in Python that we got to cover before we get to reassigning values. It's super important to know if you're going to be working with data. It's the difference between copying objects and referencing objects in Python. So I'm going to take you through an example here that will illustrate why it's important to know the difference between these two things. So I'm going to make a variable called true underscore copy underscore surveys df. And I'm going to set that equal to surveys df dot and then a function called copy. So copy, open brackets, close brackets. So true copy surveys df, probably fairly self-explanatory. It's a true copy of surveys df. We're going to get into what a true copy is in a second. Now I'm going to create a second variable here called ref, which you will see is short for reference, surveys underscore df. And I'm just going to say equals surveys df. So if I run that, we don't get an error. It's all perfectly valid code. Now, you might think that this line, ref surveys df equals surveys df, creates a new variable called ref surveys df and creates a copy of surveys df and drops it in. So we now have ref surveys df and surveys df, and they're different and distinct. But that's not how it works in Python, no sir. In Python, this code, rather than creating a copy of the data frame, it just creates a new reference to the same place. So ref surveys df and surveys df now both point to the same location in memory. They're both pointing at the same data frame. By contrast, this code that uses the copy function actually does create a whole new copy. It takes surveys df, copies it, puts it in a new variable called true copy surveys df. What this means down here, this one creating just a reference to surveys df, what it means is anytime we edit surveys df, we're going to be editing ref surveys df and vice versa, because they're pointing to the same location in memory. They're pointing to the same data frame. Whereas if we change true copy surveys df, it won't have any effect on surveys df because it's a different location in memory that it's pointing to. So let's look at what happens when we reassign some of the values within the data frame with, among the copy and the references. So if we, for example, wanted to assign the first 3 rows to be 0, just all contain zeros, we might say ref surveys data frame 0:3, using that syntax to just get that first slice of the array, or list, data frame, sorry, and set that equal to 0. So we're going to take the first 3 rows of our data frame, set the values to 0. No errors, it all works fine. If you didn't know what I had just told you, you might think that surveys df was untouched, but we can type out ref surveys df dot head, which head, you'll recall, prints out the first 5 rows of the data frame. We can see the first 3 rows are 0. If we print out the head for surveys df, we can see, even though we didn't touch it in code, the first 3 rows of that data frame are also 0. So this is, you can imagine, important to know when you're dealing with your data. You can envision some circumstance wherein you would inadvertently alter a data set you didn't want to change because you thought you were dealing with a copy. But in this particular case, surveys df and reference surveys df refer to the same data frame object. If we change either one, then the other one gets changed as well. So that's a super important thing to be aware of. Before I go on, we've covered a lot of material. What are your questions? Is there anything you'd like some clarification on? Anything that you need to know? Anything that doesn't make sense before we continue on with the next section? Yeah.
So when I try to recall like the entire like surveys DF, I get like a line of like ellipses, so it's kind of just jumping to the last chunk of it. How do I make it not do that?
Okay. The question for anybody who didn't catch it was when you print out the whole data frame. I'll demonstrate here. If you print out the whole data frame, then where am I at here? There's a few rows, and then at a certain point, you get this line of ellipses. And the question was, how do we not do that? The answer is I don't know that there is a way in Jupyter Notebooks to display the whole data set. Jupyter Notebooks automatically truncates very long data sets for reasons of concision. Having all 35,000 rows right in our notebook would be kind of a problem. But you can natively open a CSV right in Jupyter Notebooks, which will print out the whole data set for you. So that would be the option that would come to mind right away. But if you wanted to see rows that were in that dotted section, you could always slice them out of the data frame. But yeah, as far as printing the entire data frame in the notebook like this, I don't know that there's a good way to do that in Jupyter Notebooks. Okay, so any further questions that anybody might have before we keep going? No? Okay, cool. Okay, so to just review, if you want to create a copy of your data frame that will be independent, use the .copy method. Again, that looks like true copy surveys df equals surveys df dot copy. So this is the way to create a true copy of your data set. If you use the equals operator that you're familiar with from variable assignments, that will create a reference, not a copy. Okay, but let's get on with sorry. There we go. Let's get on with indexing and slicing. I'm going to delete this line here. And just to undo the changes that I did to surveys data frame, I'm going to re-import the whole thing because I don't remember what values were in it. It's pd.read csv surveys.csv. Oop, that's not how you spell surveys. That's a mistake. There we go. Okay, so now surveys df is back to its normal self. So okay, slicing subsets of rows and columns, reassigning values. Let's find out how to do this. So we can select specific ranges of our data in both the row and the column directions. We can select just a few rows, just a few columns. The way that we do that are with two functions called lock, LOC, and iloc, ILOC. Lock is primarily label-based indexing. So if you knew the name of a column, you knew the name of a row, you would be able to select your slices of data based on that. iloc, on the other hand, is primarily integer-based indexing. So if you know the index of a row or of a column, the numeric index in the data frame, you'd use iloc to get it. So let's take a look at what that looks like. if we wanted to select a subset of rows and columns, we can use iloc for that. For example, if we wanted to get the month, day, and the year out of the first three rows of our data frame, we could do that like this. Surveys _df dot ILOC. And you're going to want to use square brackets on this one, I believe. Even though it looks like a function, you're going to use square brackets as though you're doing array indexing. And you're going to pass in 0:3. It's the slicing syntax that we're familiar with from just above. And 1:4. So that will get us the first three rows, 0, 1, and 2, and columns 1, 2, and 3. Remember, 4 is one beyond where we want to stop. In this case, columns 1, 2, and 3 are month, day, and year. So if we do that and run that code, we can see we get our first three rows, 0, 1, and 2, and our month, day, and year printed out for each of them. So yeah, just a good reminder there that slicing goes up to, but does not include, the stop index that you give it, which can take some getting used to. It definitely threw me for the first little while that I was writing Python code, but you'll get used to it the more you do it. So there are a lot of other fun tricks we can do with slicing. We could do this one, surveys _df dot lock, and pass that 0, comma for our first label, and then just a colon. This is weird looking, but I will run that. And you can see this is going to get all columns. This colon right here, you'll remember that earlier I showed you that you can omit the start bound and it'll assume that you want to go from the beginning to your end boundary. If you omit the end boundary, it'll assume that you want to go from the start boundary to the end. If you omit both boundaries, it will assume you want all of it. So that colon right there is something we can pass to lock or to iloc as a way of saying, just get all the columns or all the rows. We could do the same thing in the rows section. And you'll notice here that even though we've passed in 0, 10, we've only got 2 rows. The reason for that is, you'll recall, lock is label-based indexing versus iloc, which is integer-based indexing. You can remember that by the I in front of it stands for integer. Here we've passed in 0 and 10, and since it's a label-based index, we are getting row 0 and row 10. Continuing on from that, we can expand on the idea of doing label-based indexing. We can type surveys df dot lock, LOC, again short for location. We can pass it 0 for our first index. And then for our second parameter, we're going to pass an array, or list rather. Species ID, comma, plot ID, comma, weight. So if we do that, you can see that we've got species ID, plot ID, and weight. This is printing out a little differently than above because we've just got the one row. But this is for the row 0, the 0th row. But it's given us our species ID, our plot ID, and our weight. And if we were to just print out surveys df 0, whoops, my bad. Of course, It's not a list, it's a data frame. It's different. I would want .lock 0. So, incidentally, this is actually a good opportunity to explain. I tried to do this, and I received this error, key error 0. That's because for all they may have similarities, data frames are not lists. We do have to index them specifically with the functions we've been using, lock and integer location. So if I want to get the first row, just the first row of surveys df, I have to say dot lock, and I pass it 0 for the row index, and then a colon to just say get all the columns. And you can say that, you can see that gets us our first row. And indeed, our species ID is NL, our plot ID is 2, and our weight is not a number. That not a number syntax just means that there's no, it's a null value. We'll get into nans in more depth in either later in this lesson or the next, depending on time. Finally, one other thing that we can do, surveys underscore df dot lock for location. For my first parameter here, I'm going to pass a list, 0, 10, and 35,549. And I'm going to pass in the colon to tell it to give me all of the columns. Now, just before I run this, does anybody want to speculate on what this will do, on what this will return? Any thoughts? Anything unusual about this code? Okay. If we run this, we get this interesting chunk of red here, which bears the ominous title Future Warning, which I always find a little weird. And this bit of techno jargon here, passing list likes to dot lock or square brackets with any missing label will raise key error in the future. You can use dot reindex as an alternative. And you'll note down here, this line 35,549, this row is just nans. It's only null values. The reason for that is because, you'll recall, we only have 35,549 entries in our data frame. We have that many rows, but that means the indices only go as high as 35,548. So when you try to get a row or column with an index that doesn't exist, this fails silently at the moment and spits out an entire row of nans. What this is saying, which is great, it's a kind of fancy, long-winded way to say, hey, in the future, what you just did is going to return an error that'll break your code. And what we just did being trying to get a row that doesn't exist. 35,549. So this is useful to be aware of in the future, in a future update to Pandas. The functionality is going to be changed such that you can't do what I just did. It'll return a key error. But at the moment, if you try to get a row or column that doesn't exist, it will just fail quietly and give you a row or column of null values. Warnings such as this, you're probably going to run into a few in your programming career. Warnings are different from errors in that they don't actually stop your code from executing, which doesn't mean that you can just ignore them. They can be every bit as nightmarish as errors. And they'll also usually tell you important things about your code. So even though it doesn't stop your execution, definitely pay attention to warnings, find out what they mean, and figure out whether or not that has a bearing on what you're trying to do in your code. So now there's an important difference between lock and ilock beyond the parameters you pass them to index stuff. With lock, the start bound and the stop bound are inclusive. And also, you can use integers, but they'll refer to the index label and not the position, as we've been seeing here, 0, 10. You'll also note that when I say they're inclusive, I mean, you can see we pass 0, 10, 35,549. That's what it gets. There's not this notion of a bound in the same way as there is when we're dealing with slices and with ilock. I'll show you what I mean with that. If we're going to use lock and ilock to get the slices from the slice from 1 to 4, that will return slightly different output. So if we do surveys df dot ilock, we pass that 1 to 4 and the blank to get all columns, we get this. 1, 2, 3, the first 3 rows of that slice. Or the first 3 rows of the data. Yeah, not the first 3 rows. Rows 1, 2, and 3. I'm sorry. I tripped myself up there. We went from 1 through to 4, not 0 through to 4. So we've skipped the first row. We've gone right to 1, 2, and 3. I threw myself because I saw 1 and thought first. That's an example of how 0 indexing can be confusing sometimes. On the other hand, if we do surveys dot lock and we pass it 1 to 4 and the empty slice operator, we can see that with that we actually get 1, 2, 3, and 4. So that's what I mean when I say it's inclusive. If you pass that bound to lock 1 through 4, it'll get you 1, 2, 3, and 4. But it won't get you necessarily the rows 1, 2, and 3. It'll get you the rows with the indices 1, 2, and 3. So if you, there are circumstances where those may be different things. They're not in this particular case, but if you had sorted your data frame, for example, your row indexes might be in a different order than in their numeric order. We'll see more of that in the future, I think. Just before we go on, what are some of your questions? Anything you might like to see better explained? Any questions, clarifications, comments, stuff you might like to know? Okay, cool. Well then, that means you're ready to do a challenge. All right. So, with your newfound knowledge of slicing, try these on for size. What happens when you execute this code, surveys df 0 to 1, surveys df :4, surveys df :-1? And likewise, what happens when you call these 2 lines of code? ilock 0 to 4, 1 to 4, lock 0 to 4, 1 to 4. And then just speculate a little bit on how the 2 commands are different, what the differences between their output might be. And I'll give you just a little while to work on that. Okay, you've all had a second to look that over. We're going to get back to this. So, would anybody like to anybody like to take a stab at breaking down what happens for any of these three, or all of them? Anybody run that code and have something happen for them? Okay. Let's step through it. If we go back to the code. All right, so surveys, df, 0 to 1. This should be fairly familiar. That's going to get us just the first row. Index 0 up to, but not including index 1. So just index 0. Surveys, df, :4. That too, when we run that, we get the first 4 rows, 0 to 3, starting at the beginning and going up to, but not including index 4. What about this one? Surveys, df, :-1. Somebody want to take a stab at what happens when you run that? Did I see a hand back there? Close. Yeah. Did I hear all but the last one? Yeah. Correct. If we run this, we will get every index except 35,548. This syntax up here, this -1, you can step backwards from the end of an array back to the start. So -1 will take you to the index just before the end. -2 will take you 2 steps back, -3, 3 steps back, and so on. So this tells us to go up to, but not including, the last index in the data frame. So that's super useful if you've got a big data set like this and you can't remember what the highest index is. You can use -1 to get almost all the way up to the end. Moving along, if we do surveys _df dot ilock, 0 to 4, 1 to 4. This is all pretty familiar. The first 4 rows, 0 to 3, and the columns from column index 1 up to, but not including 4. So in this case, month, day, and year. So that's good to see that still works. But what happens if we do this? Surveys df dot lock 0:4, 1:4. Did anybody try to run this? Yeah? Anybody want to say what happened when they gave it a shot? That is correct. It returns a big, gross-looking error that tells us cannot do slice indexing on class Pandas core index-based index with these indexers, one of class int, which is a weird thing to say to somebody. Does anybody want to take a stab at why we might be running into that error? Any guesses? Yeah.
So .lock is referencing the label names, and our columns aren't labeled in like 1 to 4. So in order to call them up, we need to write the names of the columns that we want to see.
That is correct. Lock is label-based indexing. So our columns aren't labeled 1, 2, 3, and 4. They're labeled record ID, month, day, year, etc. So if we wanted to get those columns, we would have to use the labels of the columns, which we can actually do right in this syntax. If I get rid of the 1 and replace it with month, and if I get rid of the 4 and replace it with year, we can see we actually get the same output as we got. Well, not the same, because we have, again, it's inclusive, so the index will take us to row 4 rather than up to row 3. But we can see that we've got month, day, and year because we referred to them by their correct labels. So yeah, useful to know. So this is all good to know how to do, subsetting your data by the indices, getting slices of data, but you can go even harder than that and do even more powerful things. We can subset on more than just the, I'm sorry. We can subset on more than just the index. We can also subset on a criteria. So we can say, get me all of the rows where this condition is true. So for example, we could do something like the following. We could type surveys underscore df, open our square brackets, so far very familiar, but then right in those square brackets, we can put a Boolean condition. Boolean is just a true or false condition. You may hear about Boolean values. Anything Boolean in a Python context just means it's either true or false. We use them for all kinds of things. In this case, we're using them for checking a condition. So let's put our condition right in there. Surveys dot year equals equals. This is important. The double equals is a Boolean operator in Python that says these two things are equal. In this case, I'm going to say the year is 2002. So the double equals is different from the single equals. Single equals is an assignment operator. It's how you say, hey, make this variable equal to this value. Double equals is a comparison operator. It's how you ask, is this equal to this? In this case, what this is going to do is it's going to give me every row in surveys df where year, this is how you get it, one of the ways you can get at surveys.year, where year is equal to 2002. So if I run that, I made a mistake. I have accidentally typed surveys instead of surveys df. Easy mistake to make. You'd think after typing surveys df this many times I'd get it right, but no. I'm only human. So, as you can see, this returns a fairly large chunk of the data set, but if you look at the year column, all of our years are 2002. So we have extracted the slice of our data set where the year is equal to 2002. So that's great, but what if we want the opposite of that, the inverse? What if we want all the ones where the survey's year is not equal to 2002? Well, fortunately, we can do the same thing. If we type surveys df and open our square brackets and type surveys df dot year exclamation point equals 2002, this syntax here, exclamation point equals, that is a comparison operator that's for determining whether or not two things are not equal. So this is going to say everything in surveys df where the year column does not equal 2002. So if we run that, we can see that the year column, we have a lot of rows, but the year column is never going to be 2002. This is going to take us right up to 2001 and then stop. And you can see we've got 33,320 rows, which if we add that to 2,229, we'll get 35,549, our whole data set. So that's an example of how you can use conditions to slice out your data set. one of the other things you can do that's quite neat, you can define sets of criteria, more than one criteria at a time. If we wanted to do that, that would look like this. Surveys underscore df, open up your square brackets, and then inside of your square brackets, you're going to open parentheses, the rounded brackets, and type surveys underscore df dot year, the right-facing pointy bracket, and an equal sign that's greater than or equal to. It's another comparison operator. 1980. And then outside those round brackets, I'm going to put an ampersand for and. Survey. Oh, yeah, you've got to open up another set of round brackets. And then type surveys underscore df dot year. Left-facing pointy bracket equals, so that's less than or equal to 1985. So what this is going to do is this is going to get us everything from surveys df, where year is greater than or equal to 1980, and less than or equal to 1985. So it'll get us all of our data from the years 1980 to 1985 inclusive. Sure enough, if we run that, we can see we get our output. We start at 1980. And if we go all the way down to the bottom of our data set, we can see we end at the last record of 1985. So yeah, using this form of syntax, where you define individual conditions inside of parentheses, you can set multiple conditions on how to manipulate your data set, on how to extract data from your data set based on more than one Boolean condition. Now I've just shown you 4 Boolean operators in Python. We've seen the double equals for equals. We've seen an exclamation point equals for not equals. And we've seen the pointy brackets combined with equals for greater than or equal to or less than or equal to. One other comparison operator you may want to know about is if we just drop the equal sign off of this, we can make that greater than and less than rather than greater than and equal to or less than and equal to. And in fact, if we run this, you can see we start at 1981 because now we have to be greater than 1980, and we will stop in 1984 because we're less than 1985, not greater than and or equal to and less than and equal to. Before we go on, what are your questions? Anything that maybe doesn't make sense or that you'd like some confirmation on, clarification?
You have to use like a number. Can you reference like a label? That makes sense. Actually, no, I can't even make this situation.
Okay.
Okay, never mind.
All right. We got a never mind on that question. Okay. Further questions? Further thoughts? All right, cool. That means you're ready to do another code challenge. So let's take a look at these problems here. Select a subset of rows in the survey's data frame that contain data from the year 1999 and that contain weight values less than or equal to 8. And compare your results with your neighbor. Strike up a conversation about it. More questions after that. Useful to know you can use the isin command in Python to query a data frame based on a list of values, like this. Surveys data frame species ID dot isin, and then a list of values. What that's saying is get everything in surveys df where species ID is in this list. That's useful to be able to do. Try using that to find all of the plots that contain a particular species, any species you like, and find out how many records contain those values. And then try out some other queries. Find one that finds all the rows with a weight value greater than or equal to 0. And my head's almost blocking this one. And also take an opportunity to play around with this tilde up here. That can be used to return the opposite of the selection that you specify. So it's roughly equivalent to is not in. So try using that to get a query that selects all of the rows with sex not equal to male or female in the survey's data. So see what you get. Take an opportunity, play around with those. I'll circle back in a moment and see how you're doing. And yeah, if you're running into any problems, grab the pink Post-it note, stick it on top of your laptop, and we'll be around to help. So yeah, I'll give you a few minutes to muddle over those ones. Okay. I don't know if you've had an opportunity to work your way through those. Not fully. Okay. In fact, I'm going to leave this as an exercise for you to take home. I do want to catch you up on the next part of this. It's quite important, and I've just checked the time and seen that we've only got about 10 minutes left. So we may, if we have time, touch on this and some other problems at the start of the next lesson. But for the time being, it can just be a way for you to think about some queries you can build out and things you can do with subsetting your data. But I want to work through this next part just before we have to wrap up for the day. So I'm sorry to have misled you thinking that we would work all the way through those problems right now. But I do want to get to this part because this is some very powerful functionality that you can use. We're going to be talking briefly now about masks. A mask is kind of a strange concept. What it is, we've touched briefly now on Boolean values, this idea of true and false. What a mask is when you supply a truth condition to an object, Python can actually create an output object that's the same shape and size as the object you provided, but has true and false for every entry in the data frame. I'll show you what that looks like. So suppose we wanted to find all of the instances where the value is null. There's a function in Pandas called isNull that looks like this. pd.isNull. If we pass that surveys underscore data frame. So I'll kick that up there so that you can all have a look. pd.isNull surveys underscore df. If we run that, and I'll just give us a little more space here, we can see this right here. So it's the same size and shape as our object that we passed it, 9 columns and 35,549 rows, but instead of our data, we have false or true. True in this case means that the value that's there in our data frame is null. False means it's not null. So this is what's called a mask. It's a version of our object that contains truth values based on the criteria that we want to evaluate. Masks are very, very powerful. I encourage you to experiment with them above and beyond what I'm about to show you. So this is super useful because this particular one can let us select only rows from our data frame where there are null values. We can do that using the condition setting syntax that we covered before. So if we wanted to do that, we could type surveys underscore df, open our square brackets, and then pass in the function that is going to generate generate our mask, pd.isNull surveys underscore df. Now, you'll recall we do have to pass in a truth condition to the index here. This line that we've written here won't work. So what we need to do is type .any, which is a function, so we need the brackets. That will give us anywhere where there's a true value in that row. And we are going to supply axis equals 1 as our parameter. Python data frames, or Pandas data frames have the concept of an axis. I believe, my helpers can set me straight on this if I'm wrong, but I believe axis 0 is from left to right along the columns, and axis 1 is from top to bottom along the rows. I'm seeing some nodding. Okay, good. It's one of those things that I always get confused. It's still a bit tricky for me, even after all these years. So yeah, this somewhat unwieldy looking line of code is going to give us every row where any row that corresponds to a row in our mask where there is a true Boolean value which corresponds to the rows that have null entries in them. Which is kind of a lot, but you'll see when I run it, all of these rows have a nan somewhere in them. So for a lot of cases, that's going to be the weight. Our weight column has a lot of null values in it. But our species code, sometimes sex, has not a number in it, null values, all the way down to the bottom. So yeah, we can see that gives us a lot of power to select specific elements from our data frame based on more complicated conditions than just the simple true-false conditions that we can set on our own. Okay, we're just about wrapping up here. So before we close down for this week, are there any? Do you have? What questions do you have? What things would you like to know? Anything you'd like to see expanded on? Something maybe you want to circle back on at the start of next lesson? No?
Is there a quick expression of is not null, kind of like giving only the rows where there is no NA, so the opposite of what we just did before?
I believe that in that case the tilde operator will work. I only briefly mentioned it, but it's the Brian's.
There's a not null function.
Ah, okay. So it's just not null, not is not null, right?
Just not null.
So we could actually do this, for example.
Yes.
Let's do it, yeah. That's interesting. PD dot not null. Oh, yes, of course. This is interesting. This particular condition is actually not super useful because this will return any row that has any false value, any not null value. Previously, we were searching for any row that had true in it. True indicating, in this case, a null value. Now we're searching for any row that has a false value in it. Yeah, it's going to be every row because every row has some data in it. So that's a funny little illustration of how you don't always get what you're expecting. You got to be a little bit careful with your conditions. But I think what you were asking for was any row where there are no null values, correct? I think that, yeah, I still think that we could use the tilde operator here to return the inverse of what we're looking for. Yeah, okay. So that right there, that'll give you the inverse of the set that you're selecting here. So this will give us pd.isNull surveys df.any axis equals 1 will give us everything that has a true value somewhere in the row, anything that has a null value somewhere in the row. This tilde will give us the inverse of the set, which in this case will be anything that has no null values in its row. So yeah, but both useful things to know, both not null and the inverse operator. Any further questions? NaN is that it's actually a Python native value. The CSV, I think if we can pull this up here. Yeah. Yeah, the CSV has blanks in it where there would be data. So when Python pulls that in, it says there's nothing there, it's a null value. So Python knows what to do with those NaNs because they're Python. Yeah, Python put them there. In the next lesson, we'll deal more with null values and how to operate with them in ways that are a little more constructive. All right, that's 1 o'clock, so I know you all have to get going. Before you take off, if you have time, please write some feedback on your Post-it notes. One constructive thing on the blue one, and one thing that maybe didn't work so well for you that you'd like to see us improve on the red one. Stick them to the door on the way out. And also, if you didn't fill in the sign-in sheet, please fill it in. It's right over there by the helpers. If you didn't sign in, please sign in. Oh, I see, yes. Okay. Yep. Hope to see you all back next week, where we will continue on with the exciting subject of data types. I know you're all stoked for that.